In this video, we'll talk a little bit more about quasi-experimental research. We've talked about quasi-experimental research strategies before, so this should be familiar to you by now. But here we'll just go a little more into detail about this topic. The term quasi refers to resembling. So this resembles experimental research, but it's not considered true experimental research. With real experiments, remember that you need true random assignment to conditions. So apart from the different types of variables that are considered quasi, like gender or handedness, we'll go over a few types of designs really quickly that fits under this umbrella. The first is a one-group post-test only design. This is when you implement an intervention in one group and then only take one measurement after that intervention. Since there isn't really anything to compare against here, this is considered one of the weakest types of designs. The next type is a one-group pre-test, post-test design. Here, your dependent measure is taken both before and after an intervention. So you take a baseline measurement of some kind, then give them the intervention, and then after some period of time, take your second measurement. This is considered within subjects in that you take your dependent measurement multiple times. But there is no kind of counterbalancing here because the order is important. You could analyze differences between pre and post interventions, but there could be a lot of things that could happen in between measurements that could influence research findings in this case. For these threats to internal validity, one is history. Here, other things might have happened between the pre-test and the post-test that caused any change in measurement. This could be an event shown on the news or a change within the participant that causes them to change or alter their behavior. Another is maturation. And here participants might have changed somehow between the pre-test and post-test. They might have grown physically or they could have learned something in between tests. Another threat is testing, which is when the act of measuring the DV during pre-test affects responses at post-test. Subjects could get better at the test or be able to anticipate the intervention better. Or alternatively, they could just get tired or fatigued from the pre-test that therefore affects the post-test. And then we have instrumentation, and this refers to when there are changes in the instrument, observers or scorers or coders, which may lead to changes in the outcome. So the experimenter or coder could be doing something different between pre and post-test, or something about your actual measurement instrument could change. So these are some things we need to think about when we have these one-group designs that could threaten the internal validity of our study. Another alternative explanation for one-group results is regression to the mean. This is when individuals who score extremely high or low on one variable on one occasion, usually the first occasion, will tend to statistically score less extremely on the next testing occasion. So with one-group designs, this could especially be a concern when researchers select people with those extremely high or low scores to begin with. Drops or increases could not just be about the intervention, but by the statistical fact that scores tend to gravitate towards normal values. Somewhat related to this is also spontaneous remission. This is the tendency for a lot of medical and psychological problems to improve or resolve over time without any form of treatment. Think of the common cold for this one. You could take cold medicine for it, but in a few days you'll probably just heal or get over your cold anyway. So sometimes participants could just randomly get better regardless of the intervention, and this would be hard to separate if we only had one group. So overall, we have to be very cautious about interpreting data from these one-group designs. A similar type of design is the interrupted time series design. Here you take regular measurements over a given period of time, and that is referred to as a time series. With the interrupted time series design, a time series is interrupted by a treatment or intervention. It could be a reduction in worker hours on worker productivity, for instance. So unlike above, it includes multiple time points, both before and after, and this at least gives us a little more confidence about the effect of an intervention, whether the pretest scores were a fluke or if it was a stable measurement, and if scores consistently improve or decrease after a treatment, or if a potential effect was just simply due to chance. Here we have an example using the worker productivity design. In the graph below, we can see that after the intervention of reducing the number of work hours, productivity was consistently higher. However, on this graph, it seems to be that changes after the intervention are quite variable, and it's more apparent here that any effect that would be found using only one measurement might be just due to noise. In line with the idea of taking multiple measurements, we can have an ABA design. Simply put, you start with a baseline measurement, and then you introduce an intervention, and then you remove the intervention one more time to see if changes kind of return to baseline values. You could alternatively start out with the intervention, then remove the intervention in the B stage, and then give the intervention back again in the A stage. These designs are good to investigate the stability of an intervention and to see how long effects can last after an intervention is removed. Moving on, let's talk a little bit about non-equivalent group designs. Non-equivalent group designs are a type of between subjects design where participants have not been randomly assigned to conditions. Remember, this is the main criteria distinguishing between quasi-experimental and true experimental studies. There are several types of these designs. One is a post-test only non-equivalent groups design. Here you have one group that is exposed to a treatment and then a non-equivalent group that is not exposed to that treatment. For example, there could be a specific teaching strategy used in different classrooms. The two classrooms weren't randomly assigned, but you still use those as your two groups. Then you introduce the teaching strategy in one of the two classes, and then you take your single measurement after that intervention. A better way to do this is to use a pre-test, post-test, non-equivalent groups design. This is when you have a treatment group that is given a pre-test, receives an intervention, and then is given a post-test. At the same time, you have your control group that is also given a pre-test, but this time they don't receive the intervention and then given the post-test. This doesn't completely solve some of the threats to internal validity, such as history or maturation, and it's not as good as a true experiment, but we're starting to get there. Next, there's an interrupted time series design with non-equivalent groups. One way to improve the interrupted time series design we talked about before is to add a control group. So you take a set of measurements at intervals over time, both before and after the intervention. So you can see here below, we have our two groups and then the intervention during the middle. Then we can see changes between our two groups and the majority of time points after the intervention in one group. This would show that this intervention could be strongly related to the changes we see in the dependent variable. On the other hand, if after the intervention the lines in both groups tend to overlap, we would conclude that the intervention probably wasn't strongly related to any changes in the dependent variable. Two more designs we'll talk about today. We have a pre-test, post-test design with switching replication. This is a further improvement in design. Non-equivalent groups are given a pre-test first, and then one group receives the intervention while the control group does not. The dependent variable is assessed again at this point to see if any differences emerge. Then the intervention is added to the control group, and finally the dependent variable is assessed one last time. A good example of this is a drug trial. With drug trials, you can initially assess differences between your experimental and control condition, but then you give the drug to the control condition eventually, so 1, both groups end up getting the drug, and 2, you can see if the improvements in the second group as well are there. One of the strengths here is that there's a built-in replication. This gives you more control over things like history effects. It would be unlikely that some outside event would perfectly align with the intervention of the first group and the delayed introduction of the intervention in the second group. This design also helps to control for other threats to internal validity, and both groups would be expected to show the same rates of, for instance, spontaneous remission or recovery. Likewise, a switching replication with treatment removal design is when the treatment is removed from the first group when it is added to the second group. So it completely switches over. So you first measure levels of depression, let's say, in patients. Then you introduce exercise to one group only, and then test to see if there are any differences between depression levels from exercise. The next step would be to remove the treatment for that experimental group and then give that exercise treatment to the initial control study group. So they flip. Then you can assess your DV one last time. Now, in addition to providing evidence for replication, you can show if any effects continue to remain over time or if they, for instance, quickly return to baseline. I know I've kind of bombarded you with different types of designs, but the main point to take away here is just to familiarize yourselves with the differences between these different types of designs, and also try to be able to identify a particular design if you're given an example study. Okay, that's it for this video, and see you next time.